Hello everyone. Today let's solve the Leetcode problem number 141, linked list cycle. So what the question says, given head, the head of the linked list, determine the linked list has a cycle in it. There is a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. So internally, position is used to denote the index of the node that tails next pointer is connected to. So note that position is not passed as a parameter. So we are returning true if there is a cycle in the linked list. Otherwise, we are returning false, right? So what we'll do here, let's come here. Let's see the example. So here 3, 2, 0 and -4 they have given. So at the position 1, it is forming a cycle from -4 to this one at the position 1, right? So we have return true. Nothing but they have explained there is a cycle in the linked list where the tail connects to the first node, 0 index, right? 0, 1. This is 1. So we are returning true. In the second one, 1 and 2. So there is a cycle in the linked list where the tail connects to the 0th node, this one. So we are returning true. In the example 3, there is no cycle in the linked list, so we are returning false. So how can we achieve this? I'll just take the example 1 and try to explain, right? So what I'll do initially, just give me a second. What I'll do initially, let's take the example 1. We have 3, 2, 0 and -4, right? So initially what we'll do, the fast and the slow pointer will be at the initial value, this one, node value. Here it will be, right? The fast and the slow. And the first step, what we'll do, we will move the slow pointer. So initially this will be slow and fast, right? So in the first, this one step, what we'll do, we'll move the slow pointer by 1. First of all, we are solving the problem by tortoise and hare algorithm. Nothing but what it will state that if there is a person X and person Y, if the person X is moving one step, then the person Y will move twice the fast as the person 1, right? So that's what the algorithm says. Here, nothing but in this example, slow is person X and fast is person Y. If slow moves one step ahead, then the fast will be moving twice as fast as the slow. So we'll be moving the slow pointer to here, this one, so, to the next one in the list, right? So now this will be slow and fast will be 0, right? Now this will be slow and this will be fast, right? Next step, what happens? So we'll be moving the slow from 2 to 0 here, right? So now this will become slow basically, right? And the fast will be we'll be moving the fast to 2, right? This one. Now this will be slow and the fast will be 2. And next we are moving the slow pointer from 0 to 4. Now we will be moving the slow pointer to 0 to 4. Nothing but this will be slow and the fast will be, now we are moving from 2 to -4, right? This will be slow and this will be fast now. So in the next step, slow moves from -4 to 2. Nothing but this one. So we'll just, this one, slow moves from -4 to 2 and fast also moves from -4 to 2. Nothing but this one. Now we have the cycle, right? So this one, from here to this one, this will be cycle. So that's what they have given here. So if it forms a cycle, we are returning true, right? So there is a cycle in the linked list where the tail connects to the first node, 0th index, nothing but this one. So from -4 to 2. So let's write the code for this. I'll just delete this one in my case. So initially what I'll do is, just give me a second. So initially we'll initialize the first pointer to the head of the linked list. Nothing but I'll just come here and just give let first equals head. Next, we'll traverse the list as long as the first and first dot next are not null. So this shouldn't be equal to null, right? So basically until that we are traversing the list. So I'll just give while first and first dot next. So this one, let's move the head, nothing but the slow pointer one step ahead, one step forward, right? So as I've explained the algorithm, when x moves one step forward, the y is twice as fast as the x, right? So in this case, I'll just give head equals head dot next, and fast here it will be fast dot next dot next. This is where next what we'll do, if the slow pointer head meets the first pointer, a cycle exists. So we had seen in the example that it formed a cycle, right? So for that one, I'll just make use of the if condition. If head equals fast, then in my case, I'll just give triple equals here. Fast, I'll just return true. So else we will be returning false. Nothing but if the loop ends, if there is no cycle present in the list, then we'll be returning false, right? In that case, I'll just return false. Simple. I'll just format this one. Let me hit the submit. So we are getting time limit exceeded, right? So somewhere I have done something wrong. Let's check. So this is good. Well, fast and fun. So yeah, here I have misspelled this one. This has to be head. So now I'll just format the this one code once. Let me hit the submit again. So now this is correct, right? So what would be the time complexity and the space complexity? So the time complexity would be big of n. Why the time complexity is big of n? Both both the pointers are traversing the entire list only once, right? Making it linear and linear time complexity. Nothing but big of both the pointers. When I say it is head and fast, right? So making it the linear time complexity. Nothing but big of n. So I'll give time complexity is big of n, and the space complexity would be big of 1. Why the space complexity is big of 1? Because only the fixed amount of extra space we are making use of for the pointers, making it constant space complexity. When I say constant space complexity is nothing but big of 1. So I'll just comment this one. So yeah, this is it. Thanks for watching.